Next question, A, B, or B, B or not C, or not B, C. So if we have a look at this, it's the middle part I'm looking at. So I'm going to multiply with the brackets, so we get B and B, or B and not C. When I look at the B and B, well, that's going to simplify down to simply a B, or B and not C. And that then can get simplified using the absorption law, getting rid of the C totally, and that just simplifies down to B. If we have a look at this, and not B and C, and A and B, or. Now there's a law of common identities, which is this structure here. It's on the sheet that I gave, which tells you if something's in this format, A, and it's negative with an and, it could be with a C, then that's just simply going to give you A, and that can be proven via truth tables. So when I look at this one up here, I just undo that scrolling, then that will give you the result B in that particular case. And then when we have a look at this, we now have got, where are we looking? A, B, or B, which simply comes down to, or B, sorry, the common identities is, which gives us that. The common identities, law of common identities, the B with a negated version of it, and just gives us B or C. So if I look at that rule, A or A and C will give us A or C. So that can be proven via truth tables. The next question uses that idea as well. Not C, F. We'll have F, A, and not B, or C. So just using different letters and different arrangement of it. So we get C, and so it's not C, C, F. We'll multiply with the brackets, so we get A, F, and B, F, or C. If we have a look at this, I'm going to bring over this term right over to on this side. So I will rewrite it. Pupils should rewrite it C and not C, F, or A, F, or B, F. So we can see that that law of common identities can be used again here just to give us C or F. And then with the A, F, and not B and F. So then I'm going to use C or, now I'm going to use F as a factor. Now in this position here, it would have given a 1, or an A, or a negated B. Now that gives us quite a good thing, because this 1 is now just going to override everything. 1 or something is just going to give us 1 or not B, and 1 or something is just going to give us a 1. And then the F, etc. F and the 1, the F and the 1 just gives us F, and plus this C or F, and that becomes the answer then for that question. Moving on, and I mean there are other questions that I will have sent you around, but if you've got A or C, I would just work back from this. So I would say something like A has come from A and A, for example. And C maybe came from a C and C or A, or something like that, right? So we'll say that must have come from that. A and A, well, I'm going to take this one first, and I'm going to say that that came from an absorption rule, maybe. So A or A, B, and with an A, so that simplifies that way. And maybe this middle C could have come from an absorption law, and we get C or A maybe there. So we could have had C or we can have C with anything. if we had another input. So we're going to have taken it from that, maybe even extend it further again by making this or this even more complex. This could have been obtained from A with an A plus B, in that case, where it would multiply out and gives us that, and A again, and what have we got here? C and C. So we could make our own questions up that way, and maybe also change the order like that.